Okay, we're going to have a look at how to do these reacting mass calculations. These are the most common sort of calculations you get at GCSE. So here's the problem. Right, what mass of water is going to be formed when you burn 10 grams of methane? Now, whenever you do these sort of calculations, you always need the balanced equation. So let's see what is that. And we're going to use this formula here. Moles is equal to mass over mr, or you can have it as the triangle there. And you've got to be able to rearrange that equation so you can interchange mass and with moles. Okay, so what's this equation showing us? It's telling us that then you have, if you have one molecule of methane, and we're not interested in the oxygen because it's only the methane and the water that we're interested in. If you have one molecule of methane, you will get 2 molecules of water. Incidentally, you will need 2 molecules of oxygen, and you'll get 1 molecule of carbon dioxide as well, but we don't really need that in this question. Okay, so if one molecule gives us 2 molecules of water, that means 1 mole of methane will give us 2 moles of water. Right, but they don't give us the number of moles here. Look, they give us the mass of methane, 10 grams. So we need to convert that into a number of moles. So it's quite handy to have the MRs of the things we're interested in here. So the MR of methane is 16 and the MR of water is 18. Okay, so here we go then. So moles of methane, that's going to be equal to the mass over the MR. That is equal to the mass we've got 10 grams. The MR of methane is 16. That is equal to 10 over 16 is 0.625. So we know here, I'll go back to the equation now, we said 1 mole of methane gives us 2 moles of water. So in that case, if we have 0.625 moles of methane, we are going to get double that, 1.25, so that's 2 times 0.625 moles of water. And now we need to convert that number of moles, because if you look in the equation, it doesn't ask us the moles of water, it asks us what mass of water is produced. So let's write that down. Mass, you rearrange the equation, mass of H2O, that's equal to the moles multiplied by the MR of water. And that is equal to 1.25 multiplied by 18 for water, and that is equal to 22.5 grams. Just a point here, which is quite often people have a tendency at this point, they say, oh, what's the MR of water? And because you've got 2 H2O there, they get tempted to put down 36, but it's not. The water molecule is always H2O. It doesn't know you put a 2 in front of it. It's always 18. And if you think that 2, you take into account of that 2 here when you multiply the number of moles there. So the MR of water is 18. You don't take any notice of that big balancing number in front. You never take any, when you look at the MRs, you never take any notice of those. Okay, now let's have a look at another example, pretty similar question. Okay, so this one, instead of saying what mass do you get, it says what mass is needed, but it's exactly the same procedure. So what mass of sodium hydrogen carbonate is needed to make 15 grams of carbon dioxide. Okay, so let's have a look at this equation. So what does the equation tell us? It tells us, we're interested in sodium hydrogen carbonate. If you have 2 moles of sodium hydrogen carbonate, well, it says 2 molecules, yeah, 2 moles, let's stick with that. You are going to get 1 mole of CO2. So I find it easy to write, so therefore 1 mole of sodium hydrogen carbonate is going to give you 0.5 of a mole of carbon dioxide. Right, the MRs again, it's useful to know the MRs. Well, we need to know the MR of sodium hydrogen carbonate is 84, and once again, you don't times it by 2. It's just 23 for the sodium, 1 for the hydrogen, 12 for the carbon, 3 times 16 equals 84. And the MR of carbon dioxide is 44. We're going to use the same equation again. Moles is equal to mass over MR. Let's cut them. I'll just copy that. I'm going to use that equation to do the interconversions again. Okay, so I'll put that up there. Okay, so all right, let's have a look at what we've got here then. So we're going to do how many moles of carbon dioxide do we make? Well, we've got the mass of carbon dioxide. We need to turn that into a number of moles. So mole CO2 is equal to the mass divided by the MR. Comes from the equation at the top left. The mass of the carbon dioxide is 15 grams, and the MR is 44. That gives us, calculator, 0.341. Okay, now there's any numbers, I've left that number in my calculator there, but I haven't written down all the numbers down, just write down 3 of them. So that's 0.341 moles. So here we know here that 1 mole of sodium hydrogen carbonate gives us half a mole of CO2. So 0.341 moles is going to give us 0.341 divided by 2. So divide that by 2, which is 0.170. Okay, so that gives us 0.170 moles of carbon dioxide. The next thing to do now is to convert this number of moles, because it doesn't ask us how many moles of carbon dioxide, it asks us what mass of carbon dioxide. Okay, so we're going to do there mass, rearrange the equation. Mass is equal to moles multiplied by the MR. So that is going to be equal to moles 0.17 multiplied by 44. That gives us a mass of 7.48 grams. That's the answer to that one. Right, so the procedure is always the same. So you write down the equation. You can then interconvert mass with moles for the substances you're interested in. Now, if you want some more practice of those, there's a couple of examples here with the answer. Okay, so there you can try those two. First one, C6H14 goes to form ethene, which is C2H4, and some ethane. That's actually that's cracking. And what mass of ethene is made by reacting 85 grams of hexane? And the answer, if you get 55.4 grams, you've done it right. Okay, here is number 4. So we've got iron oxide reacting with carbon monoxide. This is how iron is obtained from its ore. It'll give you iron metal and give you carbon dioxide. So what mass of iron oxide can react with 20 grams of carbon monoxide? And you can do it, and if you get 38.5, 38.1, you have done it correctly.